Okay, welcome to another lecture of analog communication systems. So, our topic is today is Fourier series. So, question for the same will be Arshita thoda like find the Fourier series, find the Fourier coefficients of the signal cos omega naught t and sin omega naught t. You have to find the Fourier coefficients of the signal cos omega naught t and sin omega naught t. For finding the Fourier coefficients, that means you have to just find Cn. Cn you have to find for cos omega naught t and sin omega naught t. Now, cos omega naught t, this is equal to e raised power j omega naught t plus e raised power minus j omega naught t divided by 2. Am I right? Anybody having any doubt, please tell me. Am I right? Hello?
Yes, sir.
Please respond.
Yes,
So
sir.
cos omega naught t, this is by Euler's formula. By Euler's formula. So what you will do, you will write this 1 by 2 e raised power j omega naught t plus 1 by 2 e raised power minus j omega naught t. So this is cos of omega naught t. Now, what you will do, uh, we have the Fourier series like this. We have this Cn e raised power j omega naught t n. Summation of n is from minus infinity to infinity f of t. This is your Fourier series expansion, right?
Yes, sir.
Okay. What you will do here, you will just compare this second equation with the first equation. Compare these two. On comparison, what you will get? You will get this cos of omega naught t. You can write down this 1 by 2 e raised power j n will be 1 omega naught t plus 1 by 2 e raised power j omega naught t n will be minus 1. Are you getting my point? What I have wrote here? I reformatted the equation 1 because this one is plus here, plus 1, and this one is minus 1. I wrote this. Now compare this equation A with equation second. Compare equation A with equation second. Tell me what will be the result. Compare equation second and this. Comparing equation A with equation second. Now tell me the value. On comparison, I will, okay. Tell me. On comparison, can I conclude here that C1 will be equal to 1 by 2 and C minus 1 will be equal to 1 by 2. Rest Cn's will be 0 when n is not equal to 1 or minus 1.
Yes, sir.
Am I right in this case? ठीक
Yes,
लिखा
sir.
मैंने? That means all Cn's will be 0 except C1 and C minus 1. That's what you have done here and here. All right. So in general, Fourier series coefficient for this cos of omega naught t. So, so you can conclude that Fourier series coefficients for cos of omega naught t are C1 equal to minus
Mm,
1 equal to 1 by 2.
yes.
Right? Anybody having any doubt, please tell me. Rest
No, sir.
Cn is 0 for all n's other than minus 1 and 1. For all other n's, it will be 0. So we will try to draw its spectrum. Okay. So spectrum will be drawn like this. You have n, and this is your Cn, magnitude rather. Cn at 1, it is equal to this, suppose. It's equal to 1 by 2. At C equal to minus 1, it's also equal to 1 by.
1 by.
This spectrum is also called its amplitude spectrum, complex amplitude spectrum, or you can say amplitude spectrum, right? So since Cn is purely real, there's no complex term involved, you can say phase for the same will be what? Because phase here will be, because Cn is real, because it's equal to a plus jb if you will consider Cn. Since this b here is 0, because a is 1 by 2, so you can say phi angle, that's tan inverse of b by a, it's equal to tan inverse of 0 divided by some a is here 1 by 2. Tan inverse of 0 is what? Tell me. Sorry, this is b. Oh, sorry, this is b by a. Okay, b by a is 0, 0. So angle is 0, right? Hello.
Yes, sir.
Tan inverse of 0 is 0. So you got it. So its phase will be nothing. Phase will be 0, but its spectrum will be even. Because Cn, the spectrum drawn here, it's even. It's an even spectrum, right?
Yes, sir.
This is
Yes,
even spectrum. So we will conclude something from here. What is the conclusion? If your signal is even, because cos signal is even, then you have purely real and even spectrum. So we will conclude one thing, that if your f of t signal, that here it is cos of omega naught t, everybody knows cos of omega naught t is even signal. So if you have an even signal in time domain, then its spectrum will be purely real and even. So its spectrum will be, are you noting all this?
Yes, sir.
Purely purely
yes, sir.
real and even. Done.
Yes, sir.
So that means if you have an even signal, then its spectrum, that means once you convert this to time domain, it will be purely real and even. That's what we conclude here after drawing its, because there will be no phase involved, because complex term is not there, j term is not there, so it will be 0, tan inverse of 0 is 0, there's no angle. So this is about cos omega naught t. Similarly, if I will tell you, just find the Fourier coefficients. Question is this. I will write the second question. Find the Fourier coefficients of sine of omega naught t. What you will do? Similarly, same procedure. Sine of omega naught t. Can anybody write this in terms of Euler's formula? E raised power j, tell me.
Omega naught.
Now t minus
Yes.
e raised power minus j omega naught t divided by
2.
j, right? Divided by 2j. So, but we know that f of t in terms of Fourier series, it's equal to summation of n is from minus infinity to infinity Cn e raised power j n omega naught t. On comparison of this equation, second and first, what you will get? What you will get? You will get C of 1 equal to 1 by 2j and C of minus 1 is equal to, are you getting me?
Yes, sir.
Hello? C of minus 1 is equal to minus 1 by 2j. And all other Cn equal to 0 for other n. Anybody having any doubt, any query, please tell me.
Those.
Okay. Can you draw the spectrum of this signal now? This is your n. This is magnitude of Cn. So one you have at 1, another one you have at minus 1. Magnitude of Cn will be 1 by 2 because mod of j will be always equal to, that is minus 1 rather, but you write just here 1, you can consider. So at 1, otherwise not magnitude, you just write Cn value. No need to write magnitude. Okay, Cn value at 1, tell me. It's equal to 1 by 2j. At minus 1, it will be equal to minus 1 by 2j,
Minus
right? Minus 1 by 2j. Now tell me, what do you get? This is its spectrum, complex spectrum. Is this even or odd? Is this spectrum from the figure, what you can conclude, is this even or odd? Tell me. This is odd.
like odd.
Odd. Why? Because from the, if f of minus t is equal to minus f of t, then this signal f of t is odd signal. If f of minus t is equal to f of t, then this type of signal is called as even signal. So this is an odd spectrum. So can you write its now? Phase angle. Phase will be tan inverse of b divided by a. B here is complex term, a is 0 because there is no real part. It's purely imaginary because Cn is purely imaginary. Cn value, that means 1 is equal to 1 by 2j. Similarly, C minus 1 is equal to minus 1 by 2j. And all the other, this is equal to 0 for other n values. So this is purely imaginary term because if you will take j in the numerator, you will get minus j. So this is minus j by 2. Similarly, this will be minus j minus n minus plus j by 2. So real part here is 0. So you will get tan inverse of infinity, and that's nothing but 90 value. So its phase will be constant at an angle of 90 degree.
90.
Right? Anybody having any
Yes.
question, confusion till now? Okay. So what you conclude from here? If signal, if signal, any signal f of t in time domain, obviously, in time domain, if signal in, if signal in time domain is odd, then its spectrum, that means Fourier series, will be
Odd.
purely,
Imaginary.
well done. It will be purely imaginary. and odd. Purely imaginary and
Odd. Yes, sir.
that's a conclusion from here.
Odd.
And using these conclusions, you can do many questions, objective type questions in GATE or any examination, competitive examination. Anybody have any question, conclusion, or any query, please tell me. Then we will proceed.
No, sir.
Anybody else? Hello?
Ji, sir.
Any question, confusion? Okay, in
No, sir.
general, okay. In general, I will write f of t. This is a tabular form, f of t. Then I will write down C of n, that means complex Fourier series, and its corresponding a n, b n, and a0 value. First part question means first part. If the time signal means signal in time domain, it's non-symmetric. Non-symmetric means it's neither even nor odd. So if the signal is non-symmetric, if the signal is non-symmetric, then Cn value generally it will be complex. And generally it will be complex. Complex means it will be An plus jBn. And it should follow this conjugate property. C minus n should be equal to Cn conjugate. This property is called conjugate symmetric property. And it will be having a naught value in case of trigonometric Fourier series, an value, and bn should not be equal to 0. Generally, there may be some exceptions. Now, second point. If a signal is even, like in case of cos omega naught t, tell me what will be Cn? Purely real and even.
Yes, sir.
Purely real and even. This case, bn should be equal to 0. It's always bn will be 0 and an and a naught it will not be equal to 0 generally. Now, third point. Signal will be odd signal. Then it will be Fourier
Imaginary.
coefficient will be purely imaginary and odd. Right? Purely imaginary and odd. That means an will be 0 and bn should not be equal to 0. Done?
Yes, sir.
Okay. Now we will start with the Fourier series, Fourier transform. Fourier series basic questions are done. Now we will start with the Fourier transform. Before going for the Fourier transform, I will tell you few points, important points. Now, few important points that you have to remember. First one, sine and cos, they are purely fundamental signals. Sine omega naught t and cos omega naught t, they don't contain any harmonics. They don't have any harmonic content. They don't have any harmonics. One minute. What is the reason for this? Because for finding the harmonics, you will convert the time domain signal into its frequency domain. On converting cos omega naught t to This, you got the spectrum like this. That means its value, this one value, because this is in terms of n, that's its frequency domain. This is always present at one frequency. In terms of omega, this will be present at omega naught, and this will be at minus omega naught. So it will be having its peaks at only one point, omega naught. That means it contains a single frequency. Cos omega naught t, it contains a single frequency. What does that mean? That means it don't have any harmonic component. It don't contain any other frequency. That's the reason they're called as fundamental signals. They don't have any harmonics. They are pure signals. Pure in the sense they don't have any harmonic content. Got it? Similar is the case with
Yes.
similar is will be the case with sine. Sine will also contain only one this, it has amplitude value at omega naught. It don't have any other frequency component. Means there will be power will be zero at other frequency components. Power will be, there will be some value of power at the value of omega naught. That means it has a single frequency. It contains, it is a single frequency signal. All the other frequency components will be zero. Means power will be zero at that point. If you can consider the power spectrum there. So this is a very important point about sine and cos. Okay, now we will go with the Fourier transform, fundamental signals. Then we will take some signals and try to find its Fourier transform. Fourier transform. Few points to remember about Fourier transform. This, you, Fourier transform is just a mathematical tool in which you convert your time domain signal to frequency domain in order to have a broader perspective or broader analysis of a signal. That means you get it, if you have a time domain signal, then you get its frequency domain. You try to find the frequency. What are the various frequency components contained by a signal? What are the power present at that very frequency components? Phase, phase spectrum also gives the phase of the different frequency components. So this broader analysis of a signal is possible only by converting it to corresponding frequency domain, and there are various tools for the same. So Fourier, like Fourier series, that's also a mathematical tool that was meant for what signals? Periodic and continuous signals. Fourier transform is meant for, this is
Periodic.
periodic signal. This is meant for aperiodic signals, aperiodic continuous signals, aperiodic continuous signals. Right?
Yes, sir.
Okay. If someone will say you, can you have a, can you calculate the Fourier transform of periodic signal? You will say yes, with the exception that fundamental time period should be infinity. What does that mean? If you have a periodic signal with time period equal to infinity, that means it becomes by default a periodic signal. That means you are saying the waveform will repeat after infinity. Suppose some waveform is there like this. This will repeat after infinity, and infinity is not measurable. That means it will repeat its shape after infinity. That's the reason it will become a periodic signal. So like this, you can say. So by definition, Fourier transform of a periodic signal f of t will be equal to f of omega equal to minus infinity to infinity f of t into e raised power minus j omega t dt. This is a definition of Fourier transform. This is a definition of Fourier transform. Definition, mathematical definition rather, of Fourier transform. Similarly, if you have to find f of t will be equal to 1 by 2 pi minus infinity to infinity f
Sir,
of
root 2
omega.
pi.
What?
रूट 2 पाई है या 2 पाई?
1 by 2 pi. It's not mathematics. That's something different. This is d omega. This is if you want to calculate f of t, right? If you will write this in terms of d, this, if you will try to write this in terms of df, then it will be d 1 minus infinity to infinity f of omega e raised power j omega t df. Then 2 pi will cancel out. So this is the mathematical definition. This is the mathematical definition of Fourier transform and f of t, inverse Fourier transform. Now, first question which we will do, please note down. Find the Fourier transform. Find the Fourier transform. Find the Fourier transform find the Fourier transform of the signal given below. Given below. You have to find the Fourier transform. This signal is like this. This is your t. This is your f of t. This value here is equal to, this is equal to 1. This value is here is equal to 1, right?
Yes, sir.
Okay. Now solution for the same will be this signal by default. If somebody wanna write, this is nothing but your e raised power minus at u of t. E raised power minus at u of t. Because if you will try to draw the graph of e raised power minus at, tell me it will be, graph of this will be at 0, it will be 1, right? At t equal to minus infinity, it will tend to 0. At t equal to plus infinity, it will tend to 0. And t equal to plus minus infinity, it will tend towards infinity, right? This is the signal graph for what? E raised power minus at, right? Hello,
Yes, sir.
please
Yes, sir.
respond. Okay, now since this is the only this part is mentioned in our graph, so I will try how you will write that with the signal. You will draw the graph of u of t. U of t is equal to 1 for t greater than 0. After multiplying these two signals, multiply this signal with this signal, what you will get? After multiplying these two signals, what you will get? Multiplying these two signals, you will get the only positive part of this. It's positive half cycle, like this, right? So this will be e raised power at into u of t. And this value here will be equal to 1. And this is your f of t signal. And this is a signal whose Fourier transform you have to find, right? Anybody having any question, please tell me.
No, sir.
No, sir.
Okay. So by definition of mathematical definition of Fourier transform, we have f of omega is equal to minus infinity to infinity f of t into e raised power minus j omega t
My
dt. Now put the value of ft here. It's minus infinity to infinity, minus infinity to infinity, and this is e raised power minus at u of t into e raised power minus j omega t dt. Can I say this signal is defined only from this u of t is equal to 1 when t is greater than 0, and this is equal to 0 when t is less than 0, right? So for the negative part, for the negative part, wait. So for the negative part, this will be equal to 0. So for 0 to minus infinity to 0, like this, like e raised power minus at u of t value 1 from when t is greater 0 to infinity, this plus infinity, and 1 into e raised power, I don't know what's happening, minus et dt, right?
Yes, sir.
So my equation will be then equal to 0 to infinity e raised power minus at into e raised power minus j omega t dt. Why? Because from minus infinity to 0, you have e raised power minus at, but ut value is 0 in this case. Whatever value is 0 into this, and this whole will be 0. That's the reason I'm writing the limit from 0 to infinity, right?
Yes.
Okay. So 0 to infinity. Base are same powers will be added. So you will be minus common a plus j omega and t dt. Anybody having any doubt? Because base is same e and e. You just add minus at and j omega t minus j omega t. Then I took the minus common and t is common between these two. Then you have minus bracket start a plus j omega bracket close t, right?
Yes, sir.
Okay. Now, finally, what you will get, because integration, you just remember integration of e raised power at dt is always equal to e raised power at, same value, divided by differentiation of at, and that's a value. This is the integration value. So similarly, you will do here e raised power minus a plus j omega t, that is the value of this, and divide by t is this. So t is whole common, and divide by tt, it will be
Minus
differentiation with respect to t, it will be minus a plus j omega, differentiation of dt
June.
by dt, that will cancel out. So this is the value. So ultimately you have limit will be there from 0 to infinity. So ultimately you will
Yes.
get e raised power minus a plus j omega t, t is infinity value, minus e raised power minus a plus j omega 0, and you will take this common. What is that? Minus a plus j omega is common after putting the limit. Now tell me the value. You have minus 1 by a plus j omega, e raised power minus infinity is 0, minus e raised power 0 is 1. So this is the value. Ultimately minus and minus is plus, you get a plus j omega. So Fourier transform of this signal will be equal to 1 divided by a plus j omega. So this
Yes.
is the answer of this question. Anybody having any doubt, any query, please tell me. Now we have to draw its amplitude and phase spectrum, that we will do tomorrow. But anybody having any question, confusion, or any query, please tell me.
No, sir.
No, sir.
Hope you people understood.
Yes, sir.
Okay, thank you. Tomorrow we will continue with this lecture, and we will start with this question only, and do its amplitude and phase spectrum. Draw its phase
Yes,
and
sir.
amplitude spectrum.